Probability of mutually exclusive events. Events that cannot occur at the same time are called mutually exclusive events. Like tossing a coin, right? If you toss a coin, you either get heads or tails. You can't get both. So these are mutually exclusive events, right? So let's do a problem, and this problem is on rolling a die. So you know, die has 6 faces, correct? So a die has 6 faces. Let me draw one here. And when you roll a die, you get one of the numbers on the die, which is from number 1 to number 6, right? So these are the numbers on the die from 1 to 6. Now the question here is, a die is being rolled, find each of the following probabilities. So probability of getting 2 or 5. So if you get 2, you cannot get 5. That means they are mutually exclusive. That is the first part. Now the second part is, if the probabilities are mutually exclusive, then they add up. So basically, probability of getting 2 or 5 means probability of getting 2 or means plus probability of getting 5. That is what it is, right? So what is the probability of getting 2? Probability of getting 2 is 1 out of 6. Since there is only one 2 in this die and there are 6 options, total number of outcomes could be 6. 1, 2, 3, 4, 5 or 6. So that is the probability of getting 2. How about 5? Same. 1 out of 6, right? And when you add them up, you get 2 out of 6, which is 1/3. So that is the answer for probability of getting 2 or 5. Now let's look into the next one. It says probability of getting at least 4. So when you roll, what do you mean by at least 4? That means probability of getting 1, probability of getting 2, probability of getting 3, or probability of getting 4 at least, but not 5. 5 will be more than 4. Is that okay? So that is how we have to understand this question. And as you know, probability of getting 1 is, in a die, only one option, 1 out of 6, right? So it is 1 out of 6 plus 1 out of 6 plus 1 out of 6 plus 1 out of 6. That gives us 4 out of 6, which could be simplified as 2 over 3. So that is the probability for this particular question, right? Now let's try to do the last one. Probability of not rolling 1. Not rolling 1 you could do in many different ways. So when we are saying mutually exclusive, that means we are trying to say for rolling 2, 3, 4, 5 and 6, right? So let's go with the definition and the heading. Not rolling 1, or otherwise we could have done what is the probability of rolling 1 and then take away from 1. So we can show you both the methods. So what is the probability of not rolling 1 means of rolling other numbers. What are the other numbers? Other numbers are 2, probability of rolling 3, probability of rolling 4, or probability of rolling 5, or probability of rolling 6. Now rolling each number is 1 over 6. 1, 2, 3, 4, 5. So it is 5 over 6, right? So you can do your math and get the answer. The other way of getting this answer was, like you can find probability of rolling 1. So probability of not rolling 1 should be equal to, let me do the alternate method, 1 minus probability of rolling 1. Do you see that? So it is equals to 1 minus 1 out of 6. That is the same answer, 5 over 6. Do you see that? So that is another way of solving this question. So this is kind of an important concept which you need to understand. And it's very helpful in solving such problems. So these are some practical applications where we can find probabilities using our knowledge of this subject. Now in this set of videos, you've learned a lot of probability type problems, especially simple probabilities, compound probabilities, independent and dependent ones, and now mutually exclusive events. Let's see some more variety. There is a lot to come. Hope you are enjoying the process. Thank you.